Hello, thank you for tuning in. We want to look at how to determine the angle that a straight line makes with the x-axis in a Cartesian plane without first having to draw. Now in this case, before we see how that happens, I will approach it from a diagram perspective so that we can just visualize what we are talking about here. But the main objective of this session is to determine that angle, the acute angle that a straight line makes with the x-axis without drawing. So let's consider this. Now we'll approach it from a question point of view. And the question that we have here is this example where we are asked to find the acute angle that the line y is equal to 3x over 2 minus 3 makes with the x-axis. To see this diagrammatically, when this is represented in a Cartesian plane with the x and y axis, now we'll have what we have here as shown. Now from our equation, it's already written in the form y is equal to mx plus c. Now when written in this form, this is the general form of the equation of a straight line. Then c stands for or represents the y-intercept, while m represents the gradient of the line. So like in our case here, our equation is already written in that general form. So our -3 corresponds to c, or c corresponds to -3. And therefore, coming to our diagram, the y-intercept is at -3, somewhere down here. Now we are not drawing, this is just but a sketch, so we are not drawing to scale. We are only showing the key features. And then when you substitute 0 for y in this equation, the value of x that we find as a result of substituting 0 for y is the x-intercept, which if you calculate, you can work it aside, you'll find that it is at 2, the x is 2, and that gives us the x-intercept, the point at which the line cuts the x-axis. So the equation, the line whose equation we are given here will be something like what we have here. And the angle that we are being asked for is this, which I choose to call theta. You can denote it by any other letter, provided you understand what you are doing. Now, according to your geometry, you realize that this angle here is the same as this angle. So if this is theta, then this is also theta. Of course, referred to as vertically opposite angles, which are always equal. In a Cartesian plane, the axis, the y and the x-axis intersect at a point called the origin, and at 90 degrees. So when we have a straight line cutting the x and the y-axis, now a triangle is formed, what we refer to as a right-angled triangle, which in this case I can choose to call A, O for origin, and then B. If we extrapolate that triangle A or B from the Cartesian plane, we'll have something like this, where we have our A, we have our B, and we have our O. And we have this, and the angle in question is this. So the x-intercept, that is O at A, is 2 units from the origin. So that means that the length of OA is 2 units. It could be 2 meters, 2 centimeters, 2 inches, and so on and so forth. Now, B is 3 units from the origin. So 3, of course, it's at -3 just to indicate the side of the x-axis that B is found. That's why we have -3. The -3 just denotes the negative side of the y-axis, but we know length cannot be negative. Now, whenever we have a right-angled triangle, we can use the trigonometric ratios. You remember the sine, the cosine, and the tangents from our SOHCAHTOA. If you want the sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Now, in our case here, we want to look for this angle. And now, which sides do we have? The adjacent side. Now, the side just next to the angle, like in this case, is what we are referring to adjacent side. So, OA is adjacent to theta, and you can see OB, which is 3 units, is opposite theta. So, from our SOHCAHTOA, the ratio that we can get when we have the opposite side and the adjacent side is a tangent. So in this case, if you want to get this angle, then we'll say that tan theta is equal to opposite over adjacent, which in this case is 3/2. And that gives us 1.5. That is the tangent. But remember, we are asked for the angle, the acute angle. So in this case, we have, therefore, our theta will be, using our calculator, we go for the inverse of tangent. So inverse of 1.5. Inverse, tangent inverse of 1.5, written as such, tan inverse 1.5. From your calculators or mathematical tables, you'll realize that this is actually 56.31 degrees, correct to 4 significant figures. So this is the acute angle that we are being asked for here. So in this case, for the straight line that we have here, whose equation is 3/2x minus 3, the angle that it makes with the x-axis is 56.31. But we are saying that we want to get this angle. Now here we have had to draw and then seen how we get the angle using the SOHCAHTOA. But now how can we go about the same problem without necessarily drawing? That is the basis of this clip. Now remember, when we are looking for tangent of theta, we found that tangent of theta is 3/2. And does 3/2 ring a bell? Yes, it should. From our equation, we are given as y is equal to 3/2x, or 3x/2 minus 3. Now, in this form, written in the form y is equal to mx plus c, we said that m is the gradient of a line. So what does that mean? That in this case, therefore, our m, which is the gradient of this line, is equal to 3/2. 3/2. And it is this same 3/2 that we are using to find, the angle. And we have seen here that 3/2 is actually the tangent of that acute angle that we are looking for. So what can we therefore conclude? We can therefore conclude that From that observation, we can conclude that the gradient of the straight line is equal to the tangent of the acute angle the line makes with the x-axis. The x-axis. Now, I want us to note that NB, this, of course, observation is true for all straight lines, that we maybe drawn on a Cartesian plane. That all straight lines that intersect the x-axis, we can determine the angle between them, between the line and the x-axis, by just considering the gradient of the line, because the gradient of the line is equal to the tangent of the angle that is meant. So let's look at another example, a unique example in this case. So we could be given an equation like y is equal to negative 2x plus say 5, and then you are asked to find the angle, the acute angle. Find the acute angle that line forms or makes with the x-axis. Now, in this case here, remember our gradient is negative 2. Our gradient is negative 2. Okay, gradient is negative 2. So what does that mean? If you are to look for the angle, therefore we are to say that, therefore, tan, I want you to pay attention here. If you choose to call that angle theta, tan theta will take 2. Can you tell why we are taking 2 and why and not negative 2? Now you may have learned, or you are yet to learn, that for acute angles, that is angles between 0 and 90 degrees, all their trigonometric ratios are positive. And that's why now in this case, of course, the trigonometric ratios may be negative at one point for other angles. But as long as the angle is between 0 and 90 degrees, its sine or cosine or tangent is positive. And that's why in this case, because we are dealing with acute angle, even though the gradient is negative 2, we'll take the absolute value. And that means ignoring the negativity or the negative sign. So in our case, therefore, tan theta being the acute angle, will be equal to 2. And therefore, from our calculator, theta is tan inverse of 2, which you will get to be 63.43 degrees to 4 significant figures. I hope that was clear enough. And thank you for your audience. I challenge you to go and look at other examples and do on your own. Try to approach them from a diagrammatic perspective and confirm with your calculations. At this juncture, I request you to subscribe to this channel. If you haven't, give me a thumbs up, a like, and share. And if there be any comments, you can go to the comment section and make your comments. You can ask your questions that we can respond to at a later time. Thank you so much for your time and for your audience. Let's meet in the next class. Thank you.